everyone else is here today. Emily, if you're listening, or anyone else who's listening in or recapping, right now they are writing down their section 3.5 homework number 22, that they're going to be working on in class today. I mentioned that despite the fire and, last Friday and then the one today, etc., I updated the calendar and we kind of moved our deadlines a bit. The test is now on Wednesday, giving us a work day on 3.5 today, maybe starting the review. Some people are pretty caught up. A work day tomorrow on the review itself. I'm going to give a lot more specific hints about the test tomorrow. Today is more of a, hey, let's battle this really hard section together. I'm not doing the whole homework. I can't. But if people get stuck, they can reach out to each other. If the whole class is stuck, I can do a problem here or there, depending. But what I was just reminding them as they're writing down this homework, and what I'm reminding you now, I'm back, was in section 3.5, are the problems going to be big?
Yes.
Not always, but yes. They're going to have words. They're going to have directions in the bold that if you don't read, it's going to get messy. The problems are going to be big. So wait, some of you that like to write every single word of every single this and every single that, you're going to get super overwhelmed super fast. So can I draw your attention one more time to our notes where we did an example? Ooh, if I can get to it. I think I have it from Fridays as a PDF. It'll open faster. We did an example from section 3.5, and we didn't finish all of the examples per se, and depending on your guys' questions today, we might do more. But we did get an example on Friday. Here we go. Where? We had this huge, well, we had two. We had one before that, but the one before that was crazy because, to be honest, it was this huge, like, page long of information. But at the end of the day, all we really had to do was take this equation and say, oh, plug in 80, solve, dun, 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 which there was a way to use your grapher, but in context of like you in a lab one day with a scientific calculator, the actual way to solve it with LNs we showed next as far as like, hey, we got t equals 19, that meant 19 years after 2000, which meant 2019 sometime. But then there was another big old paragraph question. And so we had to think about, okay, what's going on and what are we supposed to be solving and how are we supposed to be doing it? Now, guys, we didn't get to totally finish this one, but I think we at least did part of it. And that letter A was saying find Y when T was 5. So reading it. Now, should you put some words like virus, campus, 5,000 kids? Yeah, but then the equation and say, okay, point to an arrow. Y is total infected, and then T is time after the infection started. And then probably write down the clue about 40% or more. If they get infected, classes are canceled. But you don't have to be writing every single word. The point is, like on an SAT, to take this big old part, or the PSAT, or whatever it was, take a big old chunk of information and narrow down to what's most important. So letter A we did together on Thursday. Sorry, not Friday. We didn't have school Friday. Letter B would have been a little bit harder. And so you might see some examples in section 3.5 or those homework problems that aren't quite so like, hey, just plug in 5 and you're done. Yay! It might be a little bit messier, like when will the college cancel classes if the virus keeps growing at this rate? Well, you would have had to come up and see like, okay, wait, I need 40% or more of the students infected. So I need to come up here and remember that there are 5,000 students and say, okay, well, I need 40% of the 5,000 to be infected. Yes, we could go to a calculator, but I'm lazy. 4 over 10 is 2 over 5, and 2 over 5, 2/5 of 5,000 end up being 2,000. Otherwise, I have to go get my calculator and plug it in. That takes time. So 2,000 kids need to be infected. Wait a minute. I think one of these is how many kids are infected. Isn't that why? Oh, so we had to kind of go find our clue. 40% of the population is 2,000, and then we have to plug that into the Y. Now, you guys might not remember, but on Thursday I talked about how there is a graphing calculator way of solving this, and you will have your graphing calculator on the test. Do you remember how to use your calculator to solve this? You wouldn't have to do any more work.
Little thing, the alpha link.
Yeah. No, you don't want to use that one. That one's really good for letter A, for plugging in 5, because you could have done Y of 5. That one would have been great for the first one, because then you could have plugged this into your Y1 And then you could have used the alpha link to plug 5 in. It would have actually been, yeah, y1 of 5. And then you would have had exactly how many. But for this one, I need to, if I'm graphing it, where am I putting it?
What?
So let's assume that you already put the equation in, like for letter A to plug in 5. So this is your y1. What could you do with this guy? You could make him y2. Now, if you don't remember, Emily did bring up something really good on Thursday. She's like, or you could, instead of making this a y1 and this a y2, and we'd have to find the intersection. Does anybody realize that 2000 is way outside our zoom standard window? We'd have to zoom out, zoom out, zoom out, zoom out, zoom out a long time. Or maybe try to zoom fit and hopefully it would work. Another way is we could have actually just done y1. Do it for y1 minus 2000. Emily was like, why don't you just subtract the 2000? Then what's over on here on this side? Zeros are always going to be not the intersection feature. The intersection feature is for that one. But the 0 feature would find me the intersection point a little bit easier because zeros are always on the x-axis and I wouldn't have to worry about my zoom. Anyway, I just wanted to show you this and have it up here because today you might see some really nasty equations. Maybe you're just plugging in. Maybe you're just plugging in. But maybe you're going to have to actually solve. Now the point of the section really isn't how to use your graphing calculator. The point of the section actually comes back, oh, that's not going to help us. Come on, work with it. The point of the section is how to actually break down an equation and solve using all of your logarithmic skills that you've learned. So this one, where it was like plug in 80 and solve, we could have used our grapher. We could have done the intersection thing, or we could have subtracted, that's the intersection, or we could have subtracted and found the 0, like Emily said. But what it really wants us to be doing is how to get t alone, which is basically like 3.4 skills. So that's what it's really meaning for us to do. But if you get stuck, I just wanted you to see that there is this way of using your graphing calculator to make sure that you're right. Does that kind of make sense? Okay. At this point, guys, I just wanted to let you work. So if you want to put in music to work, that's totally fine. But please, if you get stuck, don't just stay by yourself. You have me, you have your classmates. Now's the best time to tackle this homework. And for those of you guys that have gotten behind me to ask me anything or catch up on anything, that's a good time. Sound good? Go grab a book. You have the homework written down. And if you're totally caught up, like Caitlin's working on the review, totally fine. Go work on the review too.
Can you send that?
Oh, with it all filled in?
Yes.
Got it. Okay, Emily, I'm going to pause the video. That way.
Helps.